Okay, problems number 5 and 6 on this set A from this first week. So the first one, I didn't draw the picture, kind of out of space. It was the moose problem. There was this fire and where the moose were hanging out, and then they had these land areas and how big the areas were. They give you the proportion of the total acreage and how many moose were there. And the first question said they want to see if the moose are in the same proportion as the proportion of the areas, or if they're headed towards some certain spot better. So it said perform the test, assume the conditions were met. So this is going to be a chi-square goodness of fit test. When they tell you the conditions are met, just say the conditions are met. That's all you got to say. The null hypothesis is the proportion of moose in each habitat is equal to the proportion of the areas. Or you could have said, I wrote it in two different ways. You could have said the amount of moose in each area is proportional to that area. So there's like very much the same. The alternate is that they're not equal. So we observed, if you look, 25, 22, 30, and 40, 117 moose. But then there was a percent for each one, right? So these are my list one for the goodness of fit test was the observed. And these were expected, right? 34% of 117 because of their area. 10%, 117, 10%, 45%. And these are the actual numbers. But you could just type those in as a decimal. I ran the test. I got goodness of fit test, list one, list two, 3 degrees of freedom, one less than the number of categories. Got a chi-square test statistic of 43.68. And p-value basically 0, which means I'm going to reject the null, which means there is evidence that the moose are not in the same proportion as the areas, that they're going somewhere else. And then the next question is, where are they going? So it looks like we only expected 11 here, but we got 22. We only expected 12 here, we got 30, right? So they're headed towards areas 2 and 3, which I guess were near the edge, right? Yeah, near the edge or something, so that's what they were kind of looking for. So that's it for problem number 5. Problem number 6. I didn't write down a lot because there was too much to write down on one board, so I'm going to do a little bit of reading. Also, save more space here. So this is the one where we had the magnet school and an original school that ran an experiment to see how they did on the post-test after the score they got on the pre-test. So they did all the right stuff. They sample sized, or they did a sample, blah, 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 everything else. So the first question with all the data was to perform a test to see if they did better on the one. So this would be a 2-sample t-test. We got 2 scores, 2 averages. We want to see if the one average difference is equal to so the null hypothesis, the mean difference for the magnet school is equal to the mean difference of the original school, or mean 1 equals mean 2. Or alternate was you want to see if the magnet school is better, right? So that the mean of the magnet school is greater than the mean of the original school. 2 independent simple random samples. Remember, in normal populations, we don't have that. We have small sample sizes. So there's one other thing we ran into a little bit in class, but not very often, that if your sample sizes look roughly normal, that's a pretty good indication your population is. So remember, the sample sizes need to be 30, which they're not, or the population needs to be normal, which they don't tell us. So the only thing we have to go on are then the samples. So they give us all the data here, right? X bar for the magnet school, X bar for the original school. So I just ran the test. I got a test statistic of 2.487, a p-value of 1.77%. Critical value is an inverse t, 95%. 16 degrees of freedom. There were 8 in one, 10 in the other. So 18 minus 2. Subtract 1 from each sample size, in essence, add together. So in any case, we're rejecting the null, which means, did I write it? Yeah, no, I didn't write it down. So we're rejecting the null, which means there is evidence that the magnet school worked, right? Or that the difference in the scores were better at the magnet school than they were at the original school. Then they did some regression analysis. They gave you a little computer printout here. First one said write the 2 equations. One for the magnet school, one for the original school. The data's right in here, right, where they give the slope and the y-intercept. So the 0.1811x plus 73.27 for the magnet school, 0.92x plus 9.7 for the original school. They also asked you to interpret the slope. I didn't write that down. So for the interpretation of the slope, I would say for each increase in one score on the pre-test, there's an increase of 0.1811 on the post-test. Same thing here, right? For each increase in one score on the pre-test, there's an increase of 0.92 on the post-test. Then they said, part C said, let's run a test to see if there's a relationship. So this is a slope relationship. So we have, there's no correlation, or the slope is 0, then there is a correlation, the slope is not 0. And then they said use the same printout. So let's go back to the printout. They got some p-values hiding down here, 0.706 for the first one, and 0 for the second one. Okay? So this is going to be a fail to reject the null. When you fail to reject the null is the slope is 0, so there is no relationship. So this one we failed to reject, so there's no evidence of a relationship. And this one we are going to reject. This is the original score, which means there is evidence of a relationship between the pretest and the post-test. And then the last one says, what additional information does the regression analysis give you that the mean differences don't? So if you look at the graph here, what you're going to see is that the magnet school, pretty much everyone did better on the post-test, or did high on the post-test. Didn't matter how they did. You can see they're all up there, whether they had, these are low pretest scores, high pretest scores. Everyone had a high post-test score. However, on the original school, the black ones, the people that had low pretest scores didn't do very well on the post-test either. So what I said was the magnet school, everyone did high on the post-test. At the original school, only those who did good on the pretest did good on the post-test too. Again, a pretty good example of number 6. Lots of, just kind of a little different. Nothing too tricky on that one. So that's it for 5 and 6.